Uh, hi, greetings and Hi, greetings and welcome to our presentation titled Code Red Navigating the Fallout from the APK Exploit on Android Nougat. My name is Javed Sheikh, and together with my colleagues Gauri Shankar, Shivam Sharma, and Vinay Kumar Ralla, we will explore a critical cybersecurity incident and our comprehensive response strategy. Next slide, please. Cybersecurity incident overview. Let's delve into the incident that catalyzed our cybersecurity overhaul. John, an ex company employee, downloaded a malicious APK on his Android device. This breach led to the explosion of data, sensitive data, and prompted a thorough reassessment of our cybersecurity measures. Next slide. X Company's proactive cybersecurity steps. In response to this incident, X Company undertook several key cybersecurity inactivities. We ensure all these devices were updated with the latest security patches, advocated for the use of trusted app sources, and introduced regular security reviews and training for our employees. Additionally, we implemented real time security monitoring systems for immediate threat detection. Next slide. Mobile device information. Our security analysis utilized a MEMU emulator running Android 7.1. This setup replicated the conditions of John's outdated device, providing us with realistic insights into the vulnerabilities and potential exploits. Next slide. Dynamic analysis of mobile security. We engaged in a dynamic analysis of the All Safe app. Our security professionals actively monitored network traffic and system calls, aiming to identify similar weaknesses that led to the initial breach, thereby enhancing overall mobile security stance. Next slide. Androbugs framework usage. The Androbugs framework played a vital role in our analysis. It helped us thoroughly examine the AllSafe app for any underlying security vulnerabilities, enabling us to proactively detect and replicate issues. From next, Gom is going to continue.
Hello, sir, and my fellow classmate. I'm gonna continue from here. So, MOV framework for vulnerability scanning. We have three part here: automated scanning, comprehensive report, and guiding remediation. So, utilizing a MOV framework, we conducted an automated scan the all safe APK. This can not only highlighted potential security risks, but also provided a comprehensive report that guided our subsequent remediation efforts. The detailed report generated by MOB-SF guided the subsequent remediation process. Next slide. Static analysis with APK tool. So we used APK tool for static analysis, recompiling the AllSafe APK. This allowed us to synchronize the app's resource code and the Android manifest.xml file, identifying potential vulnerabilities and understanding the app's permission requirement. The analysis of manifest files declaration was crucial for comprehending the app's permission and identifying any potential vulnerabilities. Next slide, please. Insecure intent handling discovery. Here we have potential security flow and second, unauthorized access risk. Our analysis revealed a significant risk due to insecure intent handling. This vulnerability could potentially allow unauthorized access to sensitive data, especially if proper logout protocol were not followed. If a user fails to log out properly, this flow this flow could enable unauthorized viewing of sensitive data. Next slide, please. Insecure logging practices. Here we have risk of data exposure and second security vulnerabilities. Investigation. The investigation into the app's logging practices uncovered that sensitive information was being inappropriately logged, which posed a considerable privacy and security risk. This type of insecure logging can lead to various security vulnerabilities to both users and developers. Where insecure logging can lead to various security risks for both users and developers. Next slide, please. Hard-coded credentials. Here we identified hard-coded credential within the app source code, representing a cyber security risk. This finding highlighted the critical need for more secure coding practice to prevent unauthorized access. Like we have here security risk and legal implications. In legal implications, such practices could result in legal issues and damage to app's reputation. From here, Gauri Shankar will continue. Gauri?
Yeah. So, hello guys. So, Gauri Shankar this side. So, I'm gonna start from this slide. So, we have the Firebase database configuration review. So, uh, here we have like unauthorized access risk and data integrity protections. So, in Firebase database configurations, what they have done, what we have uncovered is like in manifest file, they have this Firebase database URLs that is present. So if we are able to access that database file, which is a new NoSQL database that is provided by the Google, we will be able to see the sensitive data that is stored in the database. So these URLs doesn't have to be enabled for like viewing permissions. So next is insecure shared preferences. In insecure shared preferences, we have risk of data exposures and better data protection. So here, shared preferences were used insecurely, posing a risk of data exposure on routed devices. Encryption, better data protection. Here we have encryption and strict access restrictions are recommended to safeguard sensitive data. So what happened here is like in our user.xml file, which I have decompiled using APK tool, I was able to uncover that the username and password were present as a plain text. So in shared preferences file, we don't have to like provide the user and password information. So we don't have to store that information. So it's not recommended. So next, what we have uncovered is SQL injection vulnerability. So in SQL injection vulnerability, we have database manipulation risk and immediate attention required. That is so what we have to do in this case. So here what I have given is I have given a basic SQL injection payload, and I was able to disclose the user and password informations for like various persons who were logged into this application. So here I have a user as admin, user as Elliot Alderson. So all these users were uncovered during our like investigation during this pen testing. So next I have here is like pin bypass using Frida. So Frida is a dynamic hooking tool that we use to interact with ALSEP APK during the runtime process. So here what I have done is like I have used the pin bypass scripts from GitHub. So I have used this code. So here is authentication weakness and secure authentication recommendations. So what it is saying is like so I have bypassed the pin that is present in the application package using this JavaScript code. So I have given Frida-u-l space the JavaScript code that I have and f space the package name of Alsave APK. So once I give this Frida interacts with the Allsafe APK in dynamic runtime, and it will brute force to find the valid password so that we can log in using that password. So here we have found the password as 4863, and if we gave that to the Allsafe APK, we'll be able to log in. So here next, what we have is like root detection bypass. So the only thing that changes here is like we have used pin bypass JavaScript file. So now we are using root check.js. So what it will be having is like it has this root check libraries that will be present in the source code, and it will check for apps root detection mechanisms. So if we are using Frida with this source code, then we can bypass the root detection process, and we can install this application in a router devices also. So next, we have a vulnerable web view analysis. So in vulnerable web view analysis, what happens? The application also APK has enabled like insecure JavaScript practices. So here I was able to find a payload, JavaScript payload that works. And after giving the payload, I was able to execute my XSS payload, and the alert dialog box was showing here as well. As you can see, I'm showing this 892.854 JavaScript alert box also. So next slide, we have a certificate pinning and objection. So in certificate pinning and objection, the main reason to perform SSL certificate pinning attacks, intercept the traffic that comes within our APK file to the internet. So if we can do that, then we'll be able to see the details that is presented from the users to the internet. So I'm using objection tool, which is similar to Frida. So it also runs in dynamic runtime while the app is running. So here what I have done is I have used objection space hyphen gadget space the package name, which is infosec adventures dot allsafe space explore. So if I give that, the objection will interact with the allsafe APK app. And what I'm going to do now is I'm giving Android space SSL pinning space disable. So if I am giving this, the certificate checker codes in Allsafe APK, it will get commented, and after that we will be able to capture our network traffic from Allsafe APK application. So yeah, over to you, Vinay.
Thank you, Gauri. Hi, everyone. Comprehensive security toolset employed. Tools including Memo Emulator, Androbox, MobileSafe, APK tool, JADX UI, FRIDA, Objection, and Bubsuit work instrumental in the security analysis. So what it states is our security analysis utilized a wide range of tools, which includes Memo Emulator, Androbox, MobileSafe, APK tool, JADX UI, FRIDA, Objection, and Bubsuit. These tools were instrumental in identifying and addressing various security vulnerabilities. Next slide, please. Concluding insights and next steps. The testing revealed multiple vulnerabilities that X company needed to address. Continuous security improvements, regular audits, and adoption of best practice were recommended. So, our comprehensive testing analysis revealed multiple vulnerabilities within that AllSafe app. We recommend the continuous improvement of security measures by conducting regular audits and the adoption of best practice to address these issues. Next slide, please. X company's response and strategy. Following the incident, X company implemented mandatory security training and more stringent app download policies. These measures aim to prevent similar incidents and bolster overall mobile security. In response to this incident, X company has implemented mandatory security training for all the employees and established more strongest policies for the app downloads. These measures aim to prevent future incidents. Thank you.
Thank you, sir.
Thank you, everyone.
Thank you. Thank you.